This video is a part of my full digital guitar pedal building course. In this episode, I'll teach you how to lay out all of our parts according to our drill schematic so everything will fit nicely in the enclosure, and then how to route them all. By the end, we'll have our full custom PCB done. This course is also sponsored by PCB, a quick, cheap, and well-made solution for getting PCBs custom manufactured. I'll show you how to order through them later in the course, so stay tuned for that. So, how do we make a PCB? Well, to start, we want to hit this little green button in here. This will switch to the PCB editor. Similar screen, but overall very different tools for us to use. And before we get into any of this, there's just some settings that we want to change. So we can go to File, Board Setup, and now we see here, these are all of our layers, like literally the layers that will be on the physical PCB, and we don't need a lot of these. So all of these user ones, we're just going to totally uncheck because they clutter up so much and we won't be using them at all. Many of these other ones we will not be using, but I wouldn't just turn them off because they are things that you might use someday, but a lot of them are just for more professional factory settings and things. Some of them that KiCad's already doing some stuff. But really what we're going to be using is the FCU and the BCU. This stands for the front copper layer and the bottom copper layers. So that's where all of our actual routing will be done. And then we have our silkscreen, which we use. So this is your front silkscreen and then bottom. So if you want to put some graphics on the bottom, you can do that, or the front, you can do that. You'll see all these footprints have all those base shapes and stuff like the one that we made. And then we have the courtyard. That is one for sort of the testing, as it says here. So that's how we make sure we don't place things too close. And then another layer we'll do things starting off is this edge cuts, which is basically where we just define the shape of our PCB itself. So that should be good. We just turn off these user ones, so that'll just free up some of the clutter over here. The next thing that we can go to is this constraints here. I think some of these minimum clearances being 0 isn't the best. So I like to set these to 0.15. This doesn't change a whole bunch, but it'll just sort of put these constraints in so that if we break these own rules that we set, then the software will yell at us. And since it was originally set to 0, that means you could have distances between your actual connections be infinitely low, you know? So it's good to set us some guardrails there. The rest of them should be pretty much fine. Then we are going to come down to net classes, because if you remember, these are those groupings that we made earlier. So we made our special power one. So what we're going to do here is just make the track width of the power one 1 millimeter. That's because, as I said, the power, especially the DC jack that we're going to plug in, is pulling way more current. So we want to make sure that's a higher track width. There is an actual formula to calculate the track width that you're supposed to have, or like the minimum track width that you're supposed to have. For the sake of the daisy and all of this, I promise you these will be fine, but in the future, if you're to really get into this, that is something you will need to calculate, just because if a track width is too small for a certain current, that would be very bad. So you don't want to do that. We can honestly come in here and make this 0.25. We have so much board space, so it really isn't going to hurt us in this case. But there's other times where you might have like your track width actually be sort of changing based on where it is, but we have a pretty big board for not a lot of stuff going on, so it really doesn't matter. So we can just hit OK on that. So the next thing to talk about is just our grid sizing. You'll see all these different ones that are kind of feel random at first, but you'll see they're always referring to these inches. That's because a lot of the ways that these factories and these machines works are in the measurement mils, which is 1,000th of an inch, so 0.001 inches, as you can see here. So like 1 mil is 0.025 millimeters. We will be using this user grid typically because this is the average spacing that PCBs use, which is 10 mils. You can see with the 0.01. But to start, we want to define our board size. So for now, I'm going to set this to 1 millimeters since our Tata drill tool and everything we've done so far has been in millimeters. So yeah, we need to use this rectangle tool. And then as I mentioned a little bit earlier, edge cuts is going to be our like layer that we get to define our board size. But we need to figure out what we want. So if I pull back up our little drill tool here, we need to make sure that we make a PCB big enough that it can fit these two pots, but small enough that it can actually fit in the enclosure. So the first good way to check that would be to just search the daisy seed dimensions. So if you search it, there should be a little photo that we saw earlier, 51 millimeters. So we know that that daisy will be going here. So that's 51 millimeters. So we know we need at least that. And then we can calculate the distance between these two pots. So I like to just touch and then you can see which one each is. So we know that's the left one, meaning this would be the right one. And we can just see the distances between these two. If you can remember, the middle is 0, so this is -20 from there. So basically we can just add the absolute values of these. So that's about 40. So we pretty much want to go by this daisy seed dimensions, and we want to give it a little extra space because there will be some connections going between the sides of that. So I say we could just round that up and throw it to 60. So we know that the width is going to be 60, and now we need to calculate the height. So again, we can look at this. We know that this LED, we're going to actually put in the PCB like centered with it so that we can just wire it directly into the PCB. And then we also know that wherever this drill is, 16 millimeters below it is where our actual pins are. So meaning that the PCB probably will not actually be touching up here. So we can take this Y position, which is 38.1. Let's minus 16. And then we want to add wherever this LED is, because that is somewhere probably less than 0. So that's this 5.2, -14. So we can just plus 14 to that, and that is 36 millimeters. So I'm going to just do pretty much what we did last time, which was add about 10 millimeters to that. So we can make that 46 millimeters. It's probably more than enough space. You could have it less, but for the sake of this, adding like a few millimeters to your PCB is not going to increase the price at all. So I would just give yourself a little bit more and make sure it still fits. You could also go and Google the enclosure dimensions, but we know that these drill things line in here perfectly, so we should be totally set with that. So we want the 60 by 46, right? Yes, 46. So if we come in here, make sure edge cuts is selected, select your rectangular tool, make sure you're on the 1 millimeter grid, and then I can do this and it'll just nicely tell me. So there's 60, and then we wanted 46, and boop. So now we are good on our actual board layout. There are other things you could do, like as I mentioned before, the corners of these enclosures have these little screw things. So say you wanted your jacks to be actually mounted on the PCB, and maybe you wanted them to be mounted at the top, so you needed that to press up against it, which I do have a build that I'll show you that I did that. You could use something like the line tool, so you can draw these straight lines. I think you can hit shift space, and now it'll lock it with 45-degree angles, so I can say draw like a cutout or something. And as long as you don't have any actual gaps within your PCB, this will be totally fine when you submit it to PCBWay. So you can totally do that if you want some odd shape. But for us, this is going to sit just pretty much directly in the center of the pedal, so a rectangle will be perfect. So next thing we want to do is actually bring in all of those footprints that we set earlier, which we can nicely do by just hitting this button. So I can hit that and then hit update. And we have some warnings here. We'll ignore those for now. Just hit OK, and then boom. So there are all of our parts just nicely set out. We can see our nice footprint that we made earlier, and then all of these different jacks and the daisy itself. So let's see again what that warning is telling us. So it's saying no net found for component J2 pad 1, no pin 1 in symbol, and then the same thing for the other one. So this is exactly what I was talking about earlier, when you have a footprint that doesn't have the correct pin numbers or letters. So our jacks have this S and T, while our pins here, our pads, have 1 and 2. So if I just take out these two footprints, and we need to tell it what the actual correct things are here. So if you remember, we have our tip and our sleeve for the audio jacks here, and the sleeve is ground. So we want this pin 1, which is the one with that sort of rectangle. So typically that's an indication of ground. We want this one to actually be S. So I can set that there, and then we want this one to be T. And we can do that same exact thing here. So now hopefully when we do this again, it'll tell us we're totally fine, which it did. So now we have 0 warnings, 0 errors, and we are totally good. You'll also notice all of these blue lines. So this is just our wires. All of those wires that we set here, it is just nicely telling us which ones we need to connect. So like we see this ground goes to that ground. It also says them in the pads here. So this pot 1, if you remember, that was our connection name, and it comes all the way down to this pot 1. So it's just telling us what we have to connect them to, which is handy. But the next thing that we need to do is actually place these exactly as our schematic is, our drill schematic is. And we can pretty much do this the same way we made that footprint, which is using that move exactly little tool. So we can just place 1 and then move everything according to that 1 right there. So first I'm going to get these out of the way and just place one of our first jacks at the top left, because we pretty much know it's going to be there. We can always move these later, But yeah, we just need that starting point. And as you can see, this top circle is out of the PCB, which is exactly what we want. That is totally fine and how it should be. So now we've placed that one pot, and I like to just do the thing where I just basically overlap one. I can put them over that and then right click, and then it'll ask which one you want to select. So I'll select that footprint, and I can go to positioning tools, move exactly, make sure we reset that. And then we want to see here, we have this top left one we know is this. We want to move that over by here by these combined absolute values. So we have that 20.3 plus 20.32, which is 40.62. So we can just put that right in here, hit OK, and now those are spaced perfect. So I can do that same thing. I'm going to place this one over there, go in, make sure we select RV3, go to positioning tools, move exactly. We're going to reset that. And then if we get this up, now we need to do two moves. We need to move by the X and the Y. So here, let's just do the Y first. We have this one is at 38.1, and then this one is at 12.7. So we can do 38.1 minus 12.7, which is 25.4. So let's copy that. So we're going to say 25.4, and then we need to do the X. So we can see this is negative 20.3. So we just want 20.3 to be able to move it to the right, and then hit OK. And there it is, perfectly spaced. So there's all of our pots. And now we basically know that all of these in reference to each other are completely right, meaning that we can move these any way and they will be fine. I guess I selected the edge cuts there too. One thing you can do is I can go here, hit it, and then over here we can say locked. So now you are not able to select this at all unless you were to go down here and in the selection filter you can check that locked. But we don't really want to be able to move this around or select it at all. So I can just do that right there. So now, like I said, we can get this so it's spaced evenly. Again, this isn't totally needed, but I like it to be symmetrical. So we can select this measurement tool or do Command Shift M. And then let's just see what the entire width of this is. So we have 53.620. Also for this measurement tool, they have a couple nice things about it. You'll see, like if I were to measure the distance from here to there, or I am in that locked mode. So I can measure from here to there and it will tell me the length of the line, but it will also just tell me the total distance of the like X or Y. So if you look at that Y value, if I keep moving this and if I were to be able to move it straight, you'll see that the Y stays the same because that's the difference of this going down to here, which is really handy to do. So I can just see the difference between these, and then I could go and cross-check that with the drill schematic. So this isn't just telling you the length of this line, it will actually just tell you the difference in Y. Handy thing, but for now we just want to try and space these evenly. So I can see that that is 53.62 millimeters. So if I were to just take the total width of this, which is 60, minus 53.62, then we have 6.38, and then we would want that divided by 2, so that's 3.19. So we want the distances between this side and the actual board to be 3.19. It's probably not going to be exact. It never really is with the floating point stuff, so it doesn't really matter. But let's see, this is 2.6, so we want that 3.19 minus 2.6, and that is 0.59, meaning we just need to move all of these over 0.59. Hopefully that made sense, just kind of simple arithmetic. But I can go select all of these, right click positioning tools, and then 0.59, hit OK, and then let's see if they are reasonably equal. So that's 3.19, and this one is 3.19. So now it is symmetrical down the center. So the only thing left that we need spaced appropriately is the LED. So we see here we have this knob, which we have placed, but what we've placed is the pins that are 16 millimeters below that. So we need to just find out the distance between these two and then minus that 16 millimeters. So here is my LED, which is at negative 14, and then this one is at 12.7. So those are the differences to them if we just add those together. So they are 26.7 millimeters apart. And then if I take all that and minus 16, it is 10.7. So now I could try and do that same thing where I just place the LED over top of it. It's not going to be exact anymore because of the grids, but that's all right. Instead, I can just sort of place it down here, and now we can use our measurement tools to try and get everything exact. So we see here that this is not perfect. We are not lined up perfectly symmetrical with the center of this. Typically the measurement tool, you're able to latch on to the center of things, which is nice. So I'm at the center of the LED there, and then the center of that pad there. And you can see we are over 0.16 millimeters to the left. So we need to throw this 0.16 to the right. So let's do that. 0.16. There we go. So now hopefully if I measure the center here to there, yeah, we can see we're at a 90-degree angle now, and we are 12.6. So if we just take that 12.6 minus the 10.7, I think that would be 1.9, and we can just move that up. Exactly 1.9. But as we found earlier, moving up is actually negative. So if I hit that, now if we measure, we are 10.7 millimeters. And now since we have the center of this here, I can click that and check this. So that is going to hopefully be this value, 26.7, and we are good. So now we know that our knobs and LED are perfectly spaced, and the rest we can kind of just place so they fit nicely. And there's still a couple guidelines that we want to follow here. Typically, if you have complex or like a lot of parts, this is sort of the bulk of everything, is where you place things. That is like the most important thing, because the whole thing is trying to eliminate how long your tracks are. Tracks are what those connections are. So like you can think of your wires, they are now called tracks. So up here you can see this is where we can add our tracks, route tracks, and we will get to that soon. But first we got to place everything. And even though we don't have many things going on, there still are better and worse ways to place them. So even when placing our daisy, we still just want to think about this a little bit. So here I have my pinout, and you can hopefully tell with this footprint that this is where your micro SD is. You could also just zoom in and see all of the numbers and everything there. And we want to just see where all of this ADC is and make sure that we place that on the side, probably with the most pots, because we have 2 up here. And like I said, we want our tracks to be as short as they can be. And so if our ADC was like all the way down here, then that's just going to add all of this extra length and having to cross through all of these holes or go around it. So we just want to try and have the ADC up here. So hopefully maybe just this one will have to be a little bit longer. And then we know that the LED and the foot switch and everything are just going to be these digital pins, which there are so many on either side, so it doesn't really matter as much. So we can see all of these ADC pins are on this right side of things, which is right here. So all below here, and we can even see the pots that we've already connected, which we will be changing. But I can just come in here and hit R on that so we can rotate that way, and that should be totally good to place. Another thing I'm going to do actually is switch this over to the user grid, because as you saw with the 1 millimeter, we have a sort of pretty large gap between being able to place stuff. And if I go to the user grid, now I'm able to place them much more freely. So we don't have to perfectly get this symmetrical or anything. I'm just going to place it like that, and that should work great. And now we can place something like the foot switch, which is going to be wired on. And if you kind of can just picture it, that foot switch is below everything. So we can pretty much just place that as close to the bottom as you want. You know, give it some space. It doesn't really matter. The foot switch, it doesn't have to be like as close, because we can just make one of these pins up here the actual pin for the foot switch, which is short enough and there's nothing blocking it. The resistor goes next to the LED, so we should just place it right next to the LED. So I'm going to do that. And you can see here we have, this is the LED pin that's going to go into the daisy, which again will probably change to one of these 8s or 9s if possible. And then we have this one, which it shows our little blue line is going to connect to this. So we might as well even short the distance to this, so I can rotate this a bit, and now we're here, and then we can rotate this LED. But you'll see if I rotate it, it kind of does it somewhat annoyingly. And honestly, instead of having to deal with rotating it and then moving it, I'm just literally going to switch these around. So I can put the foot switch over there and the LED here, and then re-rotate that, place it right next to it. So now we've just shortened the distance a little bit. We'll be able to connect those right up, and then the foot switch doesn't really make any difference. We can have that go up to something there. I can probably rotate this again just so those grounds are next to each other, and now this one can connect to the 5 or the 6 or something. Another thing I'm going to do just before we forget is I'm going to select these pots and the LED, and I'm just going to lock these because we have set their position. We don't want to accidentally move them, and it could just screw up everything if you accidentally move it and then you still order it because you didn't realize. Even if it's over 2 millimeters, that could totally screw up how they fit into the enclosure. So we're going to lock them, and it's going to give this big annoying purple thing, which we could probably turn off somehow, but it's fine. So next we want to place this DC jack, which we can see this line from here is going into this. So we know that that is that V in as it says. So we want to place that close. And we also know that the jack is going to be soldered in up top here with wires. So we might as well have it on that side too. And that's a pretty short distance, so that should be fine. Sometimes I'll probably do this with the audio jacks. I literally place it under the daisy just because it makes that path incredibly short and it doesn't really add much complexity if you use, we're just soldering on wires here. So it's not that big a deal, but I don't know, I'll probably just place this one up here. And then the jacks we can see that the lines are coming in here, and you can see this one that keeps jumping around. That's just ground. And as you know, like so many of our parts have ground, so it's constantly just going to connect that to the nearest ground. And you'll see soon that we're going to do a special thing for ground, but for now I can just kind of put that one above that. And then we need this one. See how I accidentally moved the daisy there? So if that was your pot, that could be annoying. Even the daisy we could lock, but I'm just gonna not for now. So we want this one to also be there. So we can probably, oh yeah, I keep selecting that daisy. I'm actually going to lock that. So we're gonna lock, and it's gonna be all purple and weird. So I'm gonna rotate this guy so we can have that one just over there, and then this over that, because why not? So now we've pretty much placed all of our things. There's just a few steps left before we actually start routing. Mainly, we need to change where these are all headed. So this is what I was saying earlier, is that we are also, make sure you save, I haven't saved, but we want to just route these to the nearest thing. So here we want all of these pots to just be to their closest ADC, because like here we see that we just stacked them here, which is totally good. It seems pot 2 we can probably just keep there, but now pot 1 would have to cross under pot 2, and then this pot 3 would have to come all the way around, and then it would be a hassle. No matter what, pot 3 here is not gonna have the best time, but it'll probably be fine. So we just want this pot 1 to have something close to there. So let's pull up our chart. In these high 30s, we can see 35 is our highest, so that's probably where we just want to throw this. So we can put the 35 there, which is going to cause some problems with these crossing. There are ways around that, but I'm honestly just going to move it down. I think it's really fine. Again, this is probably fine practice in the context of this, since we only have these 3, but if there was even 1 or 2 more, then that's a lot of wires that are coming out from this daisy, which they are lifted up a pretty good amount with these like headers you can see. So that's about the space of there, these black little parts here. So there's all that space under there for wires to come out. But if you were to have much more than this, now you're gonna maybe be pinching wires when you close it on, which could be bad. But yeah, there's not much going on in here at all. So I feel pretty confident just putting them under the daisy. But yeah, we want this pot to go to 35, and then this pot is probably totally good there. And then the closest one here is most likely going to be one of those just center ones. So we can just look at what is above there. So like around the 30, and we can see that those are totally fine. So that's like ADC 8 and 7. So just remember that pot 1, 35, pot 2 is good, and pot 3, let's put to 30. So we can come back here, and then we can just rearrange this. So pot 1, I want to put to 35. We will have to delete that X, so I can delete the X. Pot 2 is good, and then pot 3 we want at 30, so I can delete that X there, place that there, and now I need to put those X's back, so I can hit Q and then put 2 X's. And before saving and bringing in all those changes, let's go down here and do the same thing. So we can see this foot switch is close to 5 or 6, so let's check, are those good? Yep, so we can put it to either. I guess 6 is better. And then the LED here where this resistor connects, we want to see. So those are our audio pins. So let's see if maybe 15 is good. It is. So we can put the LED to 15 and the foot switch to 6. And make sure to put your X's back. So then I'm going to hit save. I'm going to just hit the checker in the circuit so we can know if we... Yep, so it is saying that I have left all of these X's here. I have no idea how I ended up doing that. But it's good to just check these things, because obviously this doesn't really matter, but there could be things that do. Let me check that again. We're all good. And now we can come back in here, and we want to just do this again. So I can hit update PCB, and now it is rerouted. So we see pot 1 goes to that, and pot 2 should be the same. and pot 3 is now here, and then all the other ones. So now all of our wiring should be totally good. Make sure to hit save on both your circuit and PCB, and now we can start to put down our tracks. So first thing to know is what our 2 layers are. So the base sort of default PCB you can make are just these 2 layers. You'll see a lot of pedals might be 4, like that Terrarium PCB is 4. That's just so you can have less sort of interference and just much easier time routing, because you'll see that when these get complex, they are just these little puzzles. They're very fun, but it can be a lot. So we have our front copper layer and our bottom copper layer, and these are just completely separate routings that we can do. Like here, if I were to go on my front copper layer and then select this tool, which you'll see is X. So I can hit X, and now I am routing, and it'll have this sort of auto routing thing where it'll try and make your sort of range around. I wouldn't always trust it, but it can be fine. So say I were to place that there, and then we can see this 3v3 is over here. So now if I were to go place it, and we can already see that this 1 millimeter is so much bigger, so that's good because this holds power. So like in this case, I can't actually cross over this wire here. I would have to go completely around it because those are on the exact same layer. And so if those were to cross, then they would connect these 2, which would then totally short our potentiometer. But if I were to go to this bottom layer and click that, now I am able to go over to that because these are 2 separate layers. But that doesn't mean that for something like this, I am going to just perfectly start crossing everything, because this can create some issues. Now, this is where I definitely have some gaps in my knowledge because, like I said, I'm not an electrical engineer and I am not a professional PCB designer. It is a skill that I am learning, but I have hundreds of hours to go before I can accurately come on here and tell you advice about that. So what we're going to do is make what's called a ground plane a bit later. We're going to do that after we route everything, which is basically where we can dedicate this entire bottom copper layer to just being ground. And since we're going to dedicate that to being ground, it means that we don't want to start throwing all of this other stuff there, especially with dealing with something like these jacks. I'm not going to throw this here and then have this be a ground layer, because that can create some problems with mainly noise and all the voltage stuff, because we have no regulators. So all of the voltage coming from this might be a little bit like out of control and unpredictable. So we're not going to mess with that. So we want as much to be just on this front copper layer as we can without ground. And sometimes we might have to go over into that bottom layer, which for things like your pot, that can be totally fine, because this is honestly not that important, but it's also not one of the main things like our audio inputs and outputs and our DC jack. So all of our sort of ADC stuff we can not be as careful about, but the rest of it we want to make sure we are good. So that's why I sort of place those within the seat itself. But in the case of these, I would just start with all of your important things and then we can do the rest from there. So I am going to delete this. You can press U to just select the whole wire, because if you were to click, it will only click a section. So I could always just click and then hit U and then hit delete. But yeah, I'm going to just connect all of these simple things here. So I will press X and then connect that. We will connect our audio here, audio there. I'll connect this resistor there. And then we'll come and do all of these 3v3s, which unfortunately have a pretty big distance to cover, which is fine. So you see the auto thing put these like pretty close. So that's something I would be maybe a little bit cautious about, but I think it should be fine in this, because they also do put this clearance that we had set. So as long as it's not over that, then we should be good. So we want that, and then we want that short distance there. So that should be good. And now we unfortunately need this one to sort of cross all the way over. So again, like I don't like how it's having this overlap so much. So I might even have this come out just a little bit more so I can click there. So now that's locked. And then let's see what it's doing. So that should be good. And now you'll see those blue lines disappear once those are connected. So we know that all those 3 knobs are connected to our 3v3. You'll see that has created some problems for things like our foot switch, which we can deal with in a sec. But yeah, okay, so next we want to just connect all of our pots. So ones like here, I'm just going to go and select that. That looks great. We're going to get this LED. That looks fine. And then we see we have these ones that cross. And for now, I would say that something like this is a short distance. This would be totally fine to just use that bottom layer. And then here, this one, we can just wire right through here since our track width is pretty small. And then same one with this, I could also just do a blue. There are also these things called vias that I'll show. So if I wanted to just use this and then I can come over here if I hit escape and then use this via. So I can basically transfer this trace onto another layer. So now I can come select this bottom layer, go there, and then I could even put another via and then go back here. And so now if this was like a really important sort of thing, then we are minimizing the amount of space that we are on the other layer. For this case, it really wouldn't matter. It's just a foot switch. So just for simplicity, I'm going to keep it all on here. As far as I know, that doesn't make a big difference with the foot switch, but maybe it does. I'm not totally sure. So now we have some last remaining lines, but as you can see, those should all just be ground. So let's look, and yeah, I think we are all set with everything except the ground. So now this is where we can make a ground plane, which we do by making these zones. Zones aren't specific to ground planes, but there are how people do it. So we can basically just dedicate this entire bottom copper layer to just be ground. So it has all this space and we don't have to worry about really routing stuff. There are ways that you could like block off a section and have to do it, which we can check to see. But for now, we're going to go to this add filled zone, and now we have to place these little things. I'm going to set our grid back to 1 millimeter just so we can have it right on the dot. So now we click it and it will have us select the layer. So we want the bottom copper and we want our ground connection. So now that first line has been placed and it's coming out, and then I can place the second thing there. And now we can see it is starting to show us what our zone is. Then I can come down, hit that corner, and then come down, hit this one, and then come up, and you have to connect it to that first point you set. And then there we go. So now that ground plane is sort of set, or that zone is set. And now I can just hit B and it will fill that zone. So now we should see this big blue zone. And then if you are to look, we can see, like if I were to select that bottom layer, we can see where it's not filling the zone. So all these gaps between the pads, because obviously we don't want these to be ground. This isn't ground, so those aren't touching. This track right here isn't, but then all of these are being connected to it, as we can see from the little bridges there. And we can also see that all of those little connection wire things are totally gone. So our PCB is pretty much done. I'm going to hit save. But there's a few more ways that we can just check and make sure everything is good. So just like there was that ERC little checker thing with the circuit, we have the DRC, the design rules checklist, that I can hit. Let's hit run DRC, and we can see we have 0 errors, but we do have all of these warnings. So let's see what these are saying. It is saying footprint does not match copy and library connector wire, which is because we had went in and changed these. So instead of these saying 1 and 2, we made it say S and T, and that's yelling at us saying like, hey, your footprint doesn't matter. So it's just giving us a warning, which is good to know. But in our case, we don't really care. We did that very purposely. Now this is saying silkscreen is clipped by our solder mask. So let's see, that's talking about this right here. This is another thing that doesn't really matter. Same with silkscreen overlap. So it's telling us we have all these points, and it's good to know. And there can be reasons why this matter, but it really doesn't for our case. We do not care that these are overlapping. It is not going to create any issues. So we really don't have to worry about it. It's pretty much just warning you that when you submit this and get it ordered, things over here might not look exactly like they do here, because obviously like this silk screen is not going to go over the pad there. So it's just a little warning to let you know that, and same with like some of your wiring and stuff, that everything will not look exactly like what it says here. We finished the PCB. That was one of the most complicated parts done with. Before you order it, the next video is going to be all about checking your work, so we can make sure that when we order all of our parts, they will actually fit and work properly. The playlist for the full build is linked below. I'll see you there.